In the last video, we used Hardy-Weinberg's equations to work out the frequencies of the alleles. And we looked at the rather strange idea that the recessive allele, despite showing up in fewer of the phenotypes, actually was of a higher frequency than the dominant allele. And that was because of the masking effect of the heterozygous genotype. And of course, with the heterozygous genotype, you've got a large reservoir of the recessive alleles, but they just don't show up. Because tigers appear. They don't show up because they are masked by the dominant allele in the heterozygous genotype. But now let's just finish this off. We've got the idea that despite only 4/10, 0.4 of the organisms showing the recessive phenotype, in fact the frequency of the allele was significantly higher than the frequency of the dominant allele. So let's have a look how we can finish this off, and we can actually work out the frequency of homozygous dominant and heterozygous individuals. Because we've already got this, we've got q squared equals 0.4, so we know that the frequency of these, the homozygous dominant, we already know. That's 0.4. But what we want to work out now is the frequency of the other two genotypes. We know the frequency of the phenotypes, it's obvious, 0.4 for the red wing and 0.6 for the white wing. But now we can divide those 0.6 showing the dominant phenotype, we can divide those into the heterozygous and the homozygous dominant. So let's have a try at that. So we know now that the frequency of P is 0.368. So the frequency of homozygous dominant must be 0.368 squared. And if we work out what that is, and I'll just check my notes because I worked this out before, that is 0.135. Just check that. Yes, that is right. And then the frequency of heterozygous, it's 2pq. And 2pq is 2 times p, which is 0.632, times the frequency of, the frequency of q there, and the frequency of p, 0.368. And that, once we can read that a bit, ends up being 0.488. And so we can use these equations to find out from just one piece of information, and that's something as simple as the frequency of the recessive phenotype, and we can use that and these equations to work out the frequency of the dominant allele. We can look at the frequency of the different genotypes, and we can eventually work out that most of them, well, the largest proportion are heterozygous, and then we've got more homozygous recessive than we have homozygous dominant. And that kind of explains our initial finding that the frequency of the recessive allele is higher than the frequency of the dominant allele, even though our first impulse on looking at this is to think, yeah, fewer recessive phenotypes expressed, and so therefore we would think that the frequency of the recessive allele is lower. But it's not.